Namaste. This is Nataraj Pillai. Right. So today we will discuss an important parameter called pressure coefficient and how we derive the pressure coefficient for hypersonic flow is the question for the today's class. Right. So we have already discussed something from the basic subsonic flow, right? Say in the subsonic flow, we had a discussion on the elementary flows. From the elementary flows, we have three source flow, sink flow, uniform flow, source flow, sink flow. From that, we have created the doublet, correct? And then the uniform flow, doublet flow together forms a flow over a circular cylinder, and we derive a relation for the coefficient of pressure, that is Cp is equal to 1 minus 4 sine square theta for a circular cylinder and all, right? So like that, the pressure coefficient we have done so far, right? So okay, I acknowledge hypersonic and high temperature gas dynamics by John D. Anderson, right? So, in aerodynamics, the pressure coefficient are usually quoted in terms of a non-dimensional pressure coefficient. Right? So, the non-dimensional pressure coefficient is usually we define that as uh, Cp is equal to P2 minus P1 by Q1. Right? So here it's like one and two. We normally consider P1 and Q1 or the upstream static pressure, correct? So this is a static pressure, right? And this is the dynamic pressure, right? Now we know that Cp is equal to P2 minus P1 by Q1, right? Usually we use a term called, we use infinity, right? So that is like P infinity. So P infinity is usually the free stream, right? The free stream pressure, right? So like that it goes, free stream pressure, and Q infinity is the free stream dynamic. That is what our initial discussion, right? Free stream, but it is dynamic. Now it is fine. Say, let us go to here. If I consider the Q1, then it becomes of rho 1 and V1 square, right? So this is just a definition for the dynamic pressure, right? So this is a definition for uh, dynamic pressure. Okay. Here, it is again basically this we take it from the incompressible, right? This dynamic pressure relation we have considered from incompressible flow to hypersonic flow even now. And see, Um, there is a difference, like you know the difference between the total pressure and the static pressure of the free stream, right? And here the Q1 is equal to half rho 1 V1 square has not very much basic, I mean, physical significance. So in high speed flow, you remember when we draw a shock wave, right? They assume that there is a shock wave for a given wedge with an off angle theta and this angle beta. Then here we have the all the terms we consider at 1, and here we consider as 2, right? Say here the shock wave we consider the pressure P1, density rho 1, velocity v1, Mach number m1, temperature T1. Similarly, on the other side we considered rho 2, T2, V2, M2, T2, and then we consider V2, U2, and all those things. Right? So this is initially in terms of it is like before shock and after shock relation, right? We consider now. We know the basic definition, right? Cp is equal to P2. Okay. Cp is equal to P2 minus P1 by Q. Okay. So we know already that Q1, right? So we can write like here we can write, right? We already know that the speed of sound A1 is equal to root of gamma or P1, and further this can be written as root of gamma P1 by rho 1, because P by rho is equal to RT and PV is equal to RT, like that, right? So again, we know the Mach number. Let us consider Mach number M1 is equal to V1 by A1, right? So here we can write V1 is equal to A1 M1, right? So again, A1 square also can be written, right? So now this equation Q1, that is equal to, that is the dynamic pressure, is equal to of rho 1 V1 square. So that can be written as of rho 1. What is V1 square? We can write V1 square as A1 square M1 square. Correct? Now we know A1 square, right? A1 square is gamma P1 by rho 1, and M1 square is V1 by A1, and A1 square is gamma P by rho. Now let us write this equation as say 1 by 2, again rho 1. This is multiplied by A1 square is gamma P1 by rho 1, and multiplied by V1 square by A1 square. So let us consider this, like say gamma P1 v1 square by a1 square as m1 square by 2. That is equal to, right? Now, now we can go to the basic equation Cp, right? Say here we can write Cp is equal to P2 minus P1 by Q1, right? So this can be written as P2 minus P1 by gamma P1 M1 square. Here it can be multiplied by 2, right? So here, okay, this can be further written into 2 by gamma M1 square, and this is multiplied by P2 by P1 minus 1, right? So this is the equation now we have, correct? So for Cp we have this equation. Cp is equal to 2 by gamma m1 square into P2 by P1 minus 1. Now, say we can reduce this equation, right? Right? Say we already know from the basic relation, right? What is the basic relation we have? Um, say Cp Cp is equal to 2 by gamma m1 square into P2 by P1 minus 1, right? So we already know P2 by P1 from the shock relation we have derived sometimes back for hypersonic flow. So P2 by P1. This P2 by P1 is the pressure ratio of after shock and the before shock. Right? So P2 by P1 is written as 2 gamma, right? 2 gamma by gamma plus 1, 2 gamma by gamma plus 1 into m1 square and square beta. Right? This we already know. So let us substitute this in the Cp equation. Right? So we will get something called a substitute Cp, that is equal to 2 by gamma m1 square into 2 gamma by gamma plus 1 into n1 square sin square beta, n1 square sin square beta. right? So we already have an assumption, right? Say for very high Mach number, say let us say for very high Mach number in infinity, then say we can simplify uh, this equation as say this one will become insignificant, right? So we can write this equation as Cp is equal to Cp is equal to 4, right? Here our gamma and then it is 4, so this becomes 4 by m1 square into gamma plus 1 into, as usual, we have m1 square sine square beta. So we can express the yeah, this Mach number m1 square also get cancelled, and the final Cp relation can be written as 4 by gamma plus 1 sine square beta. So this is the coefficient of pressure relation for hypersonic flow in terms of beta, right? Now, say we already know the relationship between, say, theta, beta, and the Mach number relation, which represents, we have, and I hope you remember, beta that is equal to gamma plus 1 by 2 into theta, right? So here theta is a flow deflection angle and beta is a shock angle, and m infinity is the Mach number, right? So by the assumption where when theta is so small and the beta is also small, with the small angle approximation, we can write sine beta, which is equal to beta, right? So further with this equation, uh, say this equation becomes Cp is equal to 4 by gamma plus 1 into beta square, whereas beta is equal to gamma plus 1 by 2. Correct? So this can be further written as 4 by gamma plus 1 into gamma plus 1 square, gamma plus 1 by 2, right? Gamma plus 1 by 2 square into theta square. So we can write in terms of theta also, right? So this expression of Cp is equal to 4 by gamma plus 1 into beta square and 4 by gamma plus 1, probably we can say that we can cancel and finally write in terms of theta. This is valid for only the, considering the flow deflection angle to be small and for very high Mach number. Right? Right? So already we know theta beta m relations, right? And here we have the CP relation, coefficient of pressure for hypersonic flow, right? I stop at this point and say, right? Thank you very much.